All right, let's now go back to our main problem and consider the system from the very beginning. X1 prime equals 7x1 minus 3x2, and x2 prime is 10x1 minus 4x2. And in order to solve this, it turns out the first step is to write this in matrix form. And all this means for now is to put all the coefficients in a table, or what's called a matrix. Should do the matrix move, whoosh. So on the one hand, we have x1 prime and x2 prime, a vector here, the table or matrix of coefficients, 7 minus 3, 10 minus 4, and x1 of t, x2 of t. And in particular, if we call this the vector x of t, so boldface means vector, and A is the matrix 7 minus 3, 10 minus 4, then this becomes x prime of t. And in particular, our system can now be written as x prime of t equals ax of t. And that is the way we will write systems from now on. So from now on, when we say x prime equals ax, we mean the system above. And at first, this seems like just a cosmetic fix where you just put everything in neat tables, but we will see very soon why this is so useful. Because it turns out the key to solving those systems will be linear algebra. And that will be the point of the next couple of lectures. But I do want to mention one little thing, because here we have x prime equals ax. I want you to compare this with the basic ODE we had from the lecture 1. So compare this with y prime equals ay, not ai, ay from lecture 1. In fact, this is really the analog of y prime equals ay, but in the system. And before we do the linear algebra part in the next couple of lectures, I do want to mention just a couple of things. One thing is you can do the same thing with inhomogeneous systems. So let's write the following in matrix form. X prime, so x1 prime is x1 minus 2, x2 plus t squared, and x2 prime equals 4x1 plus 2t. We can also write this in matrix form. So we get x1 prime, x2 prime, some coefficients that we'll fill out in a second, x1 and x2, and maybe some other terms. Now, what are the coefficients, first of all? This is like 1x1, so we get 1 minus 2. Here we have 4, but the question is, how many x2s are in this equation? None of them. So it's really 0. And what about those other terms, t squared and 2t? Those are what are called inhomogeneous terms, t squared and 2t. So what this becomes, we have, this is x prime. This is still a and an x. And this is what's called an inhomogeneous term. We call this f of t. So There are inhomogeneous systems. Like remember that example with the double mass spring with the forcing term? System. And those will always be written as x prime of t equals ax of t plus some inhomogeneous term. And yes, there will be techniques for solving them, like bar of par, which you'll see will be very nice, and maybe also undetermined coefficients. Let's see.